Hello everyone and welcome. In this lecture we will see how to use the Gaussian elimination method to solve a linear system. So this method requires two steps. The first one is to get the row echelon form of matrix A. So for example, if we have the form AX equals B, we need to get the row echelon form of A and also its corresponding so the row echelon form usually is noted by R, the matrix R, and also the vector B prime, which is corresponding to correspond to this matrix R. So we first need to get this matrix and then do the back substitution step also on this when we get this matrix R. So the row echelon form of a matrix A is a matrix that have, for example, this for example is the row echelon form of this matrix. So the row echelon form in the case, for example, of 3 by 3 matrix is a matrix with ones here on the main diagonal and any value. So this value can be any values, for example, for here, and here we have zeros here. So this in the case of the 3 by 3 matrix, and the corresponding matrix also B prime. So each operation we did on this matrix A to get the R matrix, we must also do it on the matrix B to get the corresponding matrix B prime. So once we get the matrix, the row echelon form matrix, we can get this we can get the new form of the linear system, and once we get it, we can do the back substitution to get the solution or to get the value of this unknown. So for example, x3 here is, we get x3 here, for example, so b prime 3, so this is a constant, so b prime 1 and b prime 2 and b3 prime are some constant, so we get x3, and once we get it, we can replace it here to get x2, and once we get x2 and x3, we can replace them here to get x1. And we will see it in the example and how to get the row echelon form of a matrix. So this is the example that we did in the last lecture. We solve it with the substitution method. So for example, this method, is the matrix A here, AX equals B. So the vector X here is equals x1, x2 and x3, because we know that the number of entries in the vector X, or the number of unknowns, is equals the number of columns in the matrix A. So this matrix here is 3 by 3 matrix, so that means that we have 3 unknowns, and the vector B here is 1, 2, 3, so it's a constant vector. So first we need to get the row echelon form of this matrix A. So the row echelon form is the matrix R that has the form. In this case here we have 3 by 3, so that means we all have ones here, and any values here, this value can be any values. So this one is here, so if we write it, so this one is here, and here are zeros, here also is 0. So these ones here are called the pivots, and they must be ones, and this value can be any value, and this must be zeros. So in this case here, it's an upper triangle matrix with ones here, but when we have no square matrix, so when we have matrix that are not square, in this case here is 3 by 3 and square matrix. So when we have no square matrix, we can say that it is an upper triangular, and we can say that these entries are the main diagonal, because these are just for the square matrix. But any case, so the pivots or the value under the pivots must be equal to 0. And we need also to get B prime here, the vector B prime corresponding to this matrix. So now we need to get 0 here and 0 here in the first step. So when we call these rows here R1 and R2 and R3, so this will be R1, and this row here is R2, and this row here R3. So we will write this row here, because we won't change anything here in this step. We will later change it to get 1 here, but now we will just write it here, 2 minus 1 and 3, so this row here. And to get 0 here, to get 0 in this position, we need to, so we will just write here R1, the same row here. And to get 0 here, we need to get R2, this here, 4, to get 0 here, 4 minus 2 times 4, so it is minus 2 R1, and this 4 minus 2 is 0, because here 4 minus 4 is 0, and 2 here minus times minus will be plus, so it will be 2 plus 2, which is 4, and this one here minus 2 times 3, which is minus 2 times 3 is minus 6, so 1 minus 6 is minus 5. And to get, so let me write this correctly, and to get 0 here also, we need to take R3 plus 3 R1, because here minus 6, and to get here 6, we need to multiply R1 by 3, so it will be R3 plus 3 R1, so this row will be R3 plus 3 R1. So here minus 6 plus 6, it is 0, and here minus 1, here plus 3 times minus 1 is minus 3, so minus 1 minus 3 is minus 4, and here we have 2 plus 3 times 3, which is 9, so 2 plus 9 is 11. And we must do the same here on the vector b, so vector b will be the same row here, so it is 1, and here R2 minus 2 R1, it is 2 minus 2, which is 0, because here 2 is R2, and minus 2 times R1, which is minus 2 times 1, which is minus 2, so it is 2 minus 2 is 0, and here 3 plus 3 R1, so 3 plus 3 times 1, which is 3, so 3 plus 3, which is 6, so this is the corresponding constant to this matrix here. Some people write this matrix like that, so A and B like that, to be sure that they don't forget any step here. So this will be 2, 4, minus 6, minus 1, 2, 1, or minus 1 here, same, so 3, 1, 2, and they write B here, so 1, 2, 3, and they called it the augmented matrix, and you can see it in some videos or in some books, but here in this example we just do it directly without using this matrix. So the next step now is to get 0 in this position. So we now get 0 here, this 0 we get it, and we get this 0, and we need to get 0 here. So when we call this R2 prime and R3 prime, so we need to get 0 here. So we will write this row here, 2, minus 1 and 3, and this corresponding will be the same one here, and we will also write this row here because we want to change it in this step. So this R1 and this R2 prime, so 0, 4, and so this minus 1 here must be here, this position, and here is minus 5, and here is 0. And to get here 0, we need to sum these two rows. So this will be R3 plus R2 prime, so prime here. So this row here plus this row. So this 0 plus 0 is 0, and minus 4 plus 4 is 0, and 11 minus 5, so plus minus 5 is 6, and here it is 6 plus 0, it is 6. So what we need, so now we get the zeros here, and we need to get ones here in this position. So here one, and here one, and this one. So this one is here. So to get that, we need to, so this is we need to divide this row here by 2 to get 1 here. So it will be r1 over 2, so it is 1, minus 1 over 2, minus 1 over 2, and 3 over 2, and the corresponding constant is the vector 1 over 2. And to get 1 here, 1 in this position here, so this is 0, and here will be r2 prime, 4 over 4, so divided by 4 to get 1 here, so it will be 1, and minus 5 over 4, and here it is 0 over 4 is 0, and this one we call this row here r3 double prime, so it will be r3 double prime over, here we have 6, so we need to divide by 6, so it will be divided by 6, so these two entries are 0, and here is 6 over 6, which is 1, and here also is 6 over 6, which is 1 also. So now we get the row echelon form R, and its corresponding B prime, and we can write it like that. So x1 minus 1/2 x2 plus 3 over 2 x3, which is equals 1/2, and here 0, so in here 1 x1, so x2 minus 5 over 4 x3 is equals 0, and the last one here is x3 because these two ones are zeros, so x3 equals 1. So now we need to get to do the back substitution, so we will do it here. We'll erase this space. So we will have here x3 equals 1, and x2 here is equals 5 over 4 x3, so x2 is equals 5 over 4 times x3 here is 1, so it times 1, so 5 over 4, and x1 here is equals also 1/2 x2, which is 1/2 times x2 is 5 over 4, so 5 over 4, and minus 3 over 2 times x3, which is 1, so minus 3 over 2, and plus this 1/2 here. So that means that x1 is equals, so here is 4, and here is 2, so, and here is 2 times 4 is 8, so we need to divide by 8, and here is 5, and minus here to get 8 we multiply by 4, so minus 12, and here to get we multiply also by 4, so plus 4, which is 9 minus 12 is minus 3 over 8. So the solutions are x1, so when we erase this space here, the solutions are x1 equals minus 3 over 8, and x2 equals 5 over 4, and x3 equals 1. And when we take this x here, so, and do a times x, we will get this vector b here, and we can do it to verify that our calculation is correct. And if you remember from the last lecture, we get also the same solutions here, so that means our calculation is correct.